Alright, let's go ahead and get started with our Unit 4 Day 2 video. Just to quickly review some of the things from Day 1 about classifying triangles. We can remember that there are acute, obtuse, right, or equiangular triangles by classification of angles. But we can also classify a triangle by sides as equilateral, isosceles, or scalene. Okay? So we're going to use some of those classifications for some problem solving to start with, and then we're also going to proceed into taking a look at some angle relationships within a triangle. Okay, so for starters, let's take a look at example 1. If you need to pause this video to copy this down, you should start with doing that right now. Once you're ready to continue, go ahead and click play. But we're going to go ahead and move on in how to set up a problem. If I'm giving you this triangle and I tell you that it is equilateral, you should be able to solve for x and y. Remember, equilateral means that all the sides are congruent. So you need to mark each of these congruent as a reminder. And that means they all have the same length. So whatever 3x plus 1 ends up equaling has to be 49 meters. The same thing for 18y minus 41. There are two different variables, so we're going to use two different equations. But we do know that this side is 49. That means they're all equal to 49. So we can say 3x plus 1 equals 49. And we can say 18y minus 41 equals 39. Okay? And we can solve both of these equations to find x and y. First, solve for x. And x is 16. Then solve this one for y. Alright, now I just realized the mistake I made. This should be 49. All sides are 49. I wrote a 39 for some reason, so I'm just going to fix that. That's going to change that the way it should. 49 plus 41 is 90. So when we divide both sides by 18 for y, we get y is 5. So there's your answers for x and y. Okay? For the next problem, we can find the value of x and the measure of each side because I've given you expressions for each one. But we're told here that DEF is an isosceles triangle with DE congruent to EF. These are the two sides congruent. DE congruent to EF. Once again, pause to draw this figure and write down all this information to make sure you're getting accurate notes. Okay, so make sure you copy this down. When you're ready to continue, we will start with this. We do not need to use all three sides. In fact, we're almost never going to use all three sides, even though they do have the same variable. Even if this was equilateral, we would not use all three sides together unless I was giving you a perimeter. I'm not. We're using the congruent sides first, and then we'll go back and plug in x to figure out that side. That's the only reason I've given you that. These sides are congruent, so these are equal. DE has to equal EF. So I can plug in, or substitute, 8x minus 13 equals 5x plus 17. Subtract 5x from both sides, we get 3x minus 13 equals 17. Add 13 to both sides, 3x is 30. And divide by 3, and x is 10, which is part of your answer. But you are supposed to plug back in and find the actual measurements. When I plug back in, I should get the same thing here and here. 8 times 10 is 80. 80 minus 13 is 67. 5 times 10 is 50. 50 plus 17 is also 67. And DF will not be the same because it's isosceles. DF should be different. In this case, 10 plus 21 is 31. It's not the same as the other two, and that's okay. These are your answers that are circled. All right, so we're going to have some problems that we work on in class like these, where we work with the length of the side classifications, length of the sides classifications, equilateral, isosceles, Scalene, there's not a whole lot we can do with scalene since nothing is congruent. So we're focusing on these two. Then, we've got some problems where I don't give you the picture. And we can work with this still. We have to draw our picture first. But we need to read this and figure out what kind of picture to draw. So in example 3, I've turned over to the back of my page, or you can turn it to a new page if you want, or if you still have room at the bottom of your page, just keep working on your notes this way. If triangle GHI is isosceles, where GI and HI are congruent, before I read anything else, I'm going to draw that picture. It does not have to be drawn to scale, but you do need two sides congruent to one another. Okay, so I'm going to draw my isosceles triangle like this. GI and HI are congruent. That means G and H are down here, and I is up here. So the GI and HI are congruent. And then I'm working with expressions for these sides. It says that GH is 3 more than X, HI is 17 less than 4 times X, and GI is 45 less than 6 times X. We're supposed to find X and the measure of each side. In order to do that, we're going to write these verbal expressions as written expressions with numbers and symbols. So we're going to start with the first one given, GH. GH is 3 more than X. This more than phrase means plus. So GH is X plus 3. HI, the next one, is 17 less than 4 times X. We have to do the 4 times X first because subtraction for less than is important. So that'll be minus 17. You have to do the minus 17 after the 4X. And then GI is 45 less than 6 times X. So once again, we do the 6 times X first, then minus 45. Well, now I have expressions that go in specific places on the diagram. GH is our X plus 3. HI is 4X minus 17. And GI is 6X minus 45. So now you see the two that should equal each other, GI and HI, which we knew from the given information anyway. So I can write my equation. Since GI equals HI, I can say 6X minus 45 equals 4X minus 17. Remember that when our variable's on both sides of the equation, we need to cancel it out on one side. I'm going to cancel out the 4X by minus 4X. What we do to one side, we have to do to the other. 2X minus 45 equals negative 17. Then you would add 45 to both sides. So 2X equals 28. And divide both sides by 2. So X equals 14. So that's one of our values. Find X. That's one thing we were supposed to do. And we're supposed to find the measure of each side. GH, HI, and GI. So we're going to plug 14 in for X in each of these cases. For GH, that becomes 14 plus 3, which is 17. For HI, we would have to do 4 times 14 minus 17. And we get 39. And for GI, those are congruent to each other. Even if you want to plug it in, 6 times 14 minus 45 will still equal 39. So those are our side lengths. All right? Now we do have some other information to work on in this video. Okay, we have a couple theorems that I really want to make sure you pay attention to. One of these you already know, but it does have a specific name that we're going to use. But make sure you copy this down. Make sure you're listening to me as I read through it, though. So if you need to pause the video here to copy this information down, go right ahead. Okay. The first is called the triangle sum theorem. Okay, the triangle sum theorem is something we've talked about already. All angles of a triangle add up to 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C in any triangle ABC has to equal 180. You guys know that already. But what might be new to you is this next theorem. It's called an exterior angle theorem. Okay? An exterior angle theorem states that an exterior angle is equal to the sum of the two remote interior angles. Now, I'm going to make a note here. Make sure you copy this down. So again, pause the video if you need to. But the note is this. An exterior angle is an angle formed by extending any side of a triangle. So that makes this angle I've drawn here angle 1. I took this side of my triangle and I extended it to create this exterior angle 1. You're basically creating that linear pair where this angle is your interior angle and angle 1 is your exterior angle. Now, in quotes here, I've put this term remote interior angles. The word remote means away from. Okay? So interior angles that are away from this exterior angles would be these other two, angles 2 and 3. All right? These two will always have a sum that adds up to the measure of this exterior angle. In class, we will look at why that is, but for now, just know that that is the case. So in this case, this exterior angle 1 has a measure equal to the sum of angles 2 and 3. Okay? So we can use this information to do some problem solving in example 4. Example 4, I want you to find the missing angle, so find x in each of these cases. Okay? And in the last one, you've actually found a variable x for several different pieces. Okay, for part A, remember that all three angles add up to 180. So, if I do 40 plus 70, that's 110. And if I take that 110 away from 180, I get that x has to equal 70 degrees. Okay? On part B, this is using this exterior angle theorem. We are given two remote interior angles and an exterior angle. Remember that the exterior angle is equal to the sum of the remote interior angles. So all we have to do is add those together. 74 plus 35 gives us that x equals 109 degrees. Now, on part C, it takes a little bit more work. I didn't leave myself a lot of room, but I'm going to come up here and do some of this work. To do part C, we're going to add all three of these expressions up to equal 180 degrees. So x plus 3x plus 2x plus 30, there's your three angle expressions, has to equal 180 degrees. So I'm going to combine like terms. 1 plus 3 plus 2 is 6x plus my additional 30 equals 180. Subtracting 30 from both sides gives us 6x equals 150. If I divide by 6, I get that x is 25. That means I have a 25 degree angle here, a 75 degree angle here, and if I do 2 times 25, that's 50, plus 30, I get an 80 degree angle there. Okay? I'll zoom in a little bit so you can see that work. So that wraps up our notes. We're going to do a lot more examples like these, especially this one, where we use some algebraic expressions, once you come into class next week. So make sure you've taken good notes and you are ready to work on things in class.